All right. Hello, everyone. My name is Bruno Ribeiro, and I would like to welcome everyone to the series of webinars on Nowcasting Operations and Techniques, Perspectives for South America. So these webinars are supported by the World Meteorological Organization, a World Weather Research Program within the Nowcasting and Mesoscale Research Working Group activities. And they happen on the first Friday of each month. And we would like to thank everyone who has registered for this seminar. And each webinar requires a different registration, so please keep tuned to in our webpage for the future ones. And before we introduce today's speaker, I would like to give you a few instructions. So this webinar is being recorded and transmitted online at the University of São Paulo Department of Atmospheric Sciences YouTube channel, and where we will also be posted later, so if you want to watch it again. And all the links will be on our website. And please keep your microphone muted and cameras turned off all the time. And our speaker will give his presentation, and then we will have time for questions and answers. Questions must be posted in the chat here at Google Meet or at YouTube, and we will be looking for them. And they will be responded after the presentation only. Now, Rachel.
So our speaker today is Pieter Groenemeijer, Director of the European Severe Storms Laboratory, ESSL for short. So Pieter has a degree in physics and astronomy from Utrecht University in the Netherlands with a specialization in meteorology. Also has a master's from the same university and a PhD from KIT Institute in Germany. He was always fascinated by severe weather, and in 2002, he spent a semester at Oklahoma University in the United States, and of course got inspired by the Severe Prediction Center and the National Severe Storms Laboratory. During that visit, he had the pleasure to meet the mastermind of ESSL, Dr. Nikolai Dotzek. And meanwhile, Pieter also established the European Severe Weather Database, which became part of ESSL later on. So Pieter, thank you very much for accepting the invitation here for this webinar, and the floor is yours.
Yeah, thank you very much, Rachel. Of course, it's my pleasure to give a presentation and show you more about the development of the ESSL in recent years. So and we have a couple of activities that are really very relevant for warnings and nowcasting. So I think it fits quite well in the series here. So what I'm trying to share my screen here. I think we're getting there.
Yeah, it's here.
Very good. So, actually, the ESSL team is still a little bit small. As you can see here on the right, all of our personnel still fits on the introduction slide. So we are a dedicated center for severe weather research and training. And we're also a non-profit organization. And our legal form is an association, which means that we have members. And these members are individual scientists, but also a number of national meteorological services, and UMETSAT and ECMWF as well, and a number of research institutes, and some reinsurance members. And we actually, as an association, we have a number of goals, and these goals were already set in the time when our founder, Nikolai Dotzek, organized the very beginnings of what would become ESSL. And they were defined as performing and supporting severe weather research at the European level. And an important way that we support research for other researchers is that we maintain a database of severe weather events. We also try to support the communication of scientists, and in order to do that, we organize or support the European Conference on Severe Storms, a series of conferences that takes place every 2 years, and that we co-organize with partner organizations somewhere in Europe. At some point in 2012, there was a second part of ESSL that was founded called ESSL Science and Training, because we felt that there was a part missing. And this is the part of ESSL where we do training for weather forecasters. We organize seminars on various topics. We have several types of workshops. And we organize the ESSL Test Bed. And I think that that will be quite of interest to those interested in forecasting severe storms. So I will tell a little bit more about it later. The ESSL is located, so these two ESSLs, they're located in two different locations, actually even in two different countries. The one ESSL is near Munich in Germany, and the other ESSL is very close to Vienna, and that is where our research and training center is located. And you can see a small picture here in the corner of the slide. But let's go to the content of the type of stuff that we do. So very important is the European Severe Weather Database, because it really forms the basis for a lot of research. It is not only a database with a really high number of severe weather reports, but it is also used by a very high number of researchers. And we've actually seen that there are already close to 300 peer-reviewed papers that somehow cite the data, so that use it more or less intensively for their studies. So in that sense, it has really become very successful. And if you would look at just 1 year of data that we collect in the database, this was the last year, 2021. So I just put this together for our annual report, and you can see the different types of severe weather that occurred in Europe. And it's very clear that actually severe weather occurs everywhere in Europe. It only differs a little bit from which regions we get most reports. There are still regions where we are struggling a bit with getting enough reports. For example, here Albania is almost empty, but it's almost guaranteed that there was severe weather there as well. Another thing, another aspect of this database is that the amount of data or the amount of reports is increasing very strongly from 1 year to the next. And we can not use this data set directly to detect any climate change trends, as you might already imagine, because our network of partners that help collect these reports grows really a lot from 1 year to the next, which means that any other signal is very easily disappears in this amount of data. But that being said, you can still see that, for example, this 2017 had a very high number of severe wind reports. So there's some variation. You can say something about this interannual variability, but not the full story. So which kind of reports do we actually collect? Well, there's a whole number of reports, and I will now focus a little bit on the 4 convective weather events. So we have hail, we have tornadoes, flash floods, and we also have severe wind gusts. The way that we collect this data is that we really retain the individual reports, except for tornadoes, but for each of these other events, we really retain the individual locations where this severe weather was reported, and we don't try to cluster them into like tracks of hailstorms, for example, because this is something that is always a little bit subjective, and when you do that, you could actually lose some essential information. So we refrain from doing that, even though some of the reinsurance people that contact us and that would like to work with our data, they would like us to do these kind of things. Well, impact-based forecasting is a very important important idea, especially in the last few years, where it is often said that meteorological services should issue warnings that are focused especially on those severe weather events that have an impact, and that you should take into account. You should take into account these impacts, for example, on when you determine the seriousness of the warning, like the warning level. So it is also very important that we record the impact of these various events, and actually we do so, and we now have, for example, this table that the reporting person, sometimes it's ESSL personnel, sometimes it's volunteers that we work with, that they can fill out, and in this way we get a really nice image of these impacts. For example, this windstorm that occurred early this year in February across the center and the west of Europe. There were really a lot of different impacts reported. Actually, you can see here in the Netherlands, there were a lot of roofs damaged and even sometimes blown off. There was actually one building destroyed here and here. And to the east, the damage was more concentrated to fallen trees. And well, there's a lot of interpretation that you can do, but at least one of the things that is nice is that if you record it in this way, you can get this spatial overview. Another thing that we record are the human impacts, and I mean then especially the injuries and fatalities that occur with these severe weather events. They are much better recorded than, for example, financial losses, because financial losses are really difficult to obtain. Usually insurance companies have a better idea of financial losses, and they are not very willing to share their data, and usually if there's any estimates, they will come really much later. But if you look at this map here, these are the recorded weather-related fatalities that we have in the database. You can see how it really changes from one country to another, how it differs from one country to another. That, for example, here in eastern parts of Europe, there are relatively a high number of fatalities due to lightning, probably because there is more work being done outside compared to Western Europe. And in Western Europe, actually, well, around the Alpine countries, the avalanches that we also include in here are really a dominant thing. And the very deadly flood that occurred last year in Germany and Belgium really dominates these statistics now for these two countries, where really a lot of people have, in a relative sense, were killed by flash floods. So sources of these data are both ESSL personnel and voluntary observers, and most of this data is collected from media reports, so newspaper articles or broadcast TV stations that have websites, but also from social media. Here you can see an animation of what a specific severe weather event looks like. This was a really devastating event that happened only about 2 weeks ago in the Mediterranean area. This was actually a bow echo or a derecho even that hit the island of Corsica first, and right here, and then it moved towards Italy, and in Italy it produced even more wind damage, and ultimately it even moved into these regions of Slovenia and Austria and the Czech Republic, producing more damage and also a number of fatalities. In total, 12 people were killed by this storm. So looking at this animation, you can see that you can get quite a good impression of what happened with this storm system as it moves through this region. Now going to one specific hazard, tornadoes. Tornadoes are one that have always had a lot of interest, especially because at the very first series of these ECSS conferences that was organized in France in the year 2000, one of the reasons for this first conference was for scientists to come together to discuss whether tornadoes actually happened in Europe or not. And I think this map will really give a very clear answer to that question, because tornadoes are really not that rare at all. And in some countries, well, you can see, of course, some national borders here, and you can see that the collection of tornado reports has been a little bit more efficient, or people have looked a little bit further back in time, because these are all the tornadoes starting from the year 1900. But you can see that they're really happening everywhere, and sometimes even violent tornadoes occur of F4 or F5 intensity. And yeah, during the last number of years, so since 2005, the number of tornadoes is actually quite constant in the database. There are some years with a little bit higher activity and a couple of years with somewhat lower activity. Now I want to say something about not only about the quantity of the data, but also about the quality of the data and the importance of that. So in order to make good risk estimates of very rare events that comparatively tornadoes still are, you need to know exactly what their intensity was and how this intensity was distributed across the area that they affected. In order to do that, ESSL has started the initiative to develop an international Fujita scale. The Fujita scale, of course, being the scale that is commonly used to rate tornadoes, and the enhanced Fujita scale is the newer US version of that scale. So here you see two pictures of violent tornadoes in Europe in the background. And actually this last tornado that happened last year on the 24th of June in the Czech Republic is one from which we really learned a lot. So our motivation was actually that, of course, and this is also taken care of in other scales or in other methodologies to rate tornadoes, that objects damaged by tornadoes can have various amounts of damage, various degrees of damage, so to say. So little damage, minor damage. In the case of a house, a roof gone, walls collapsed, you can get this through a range of increasing damage. But of course, there's also different structures that can be affected. You can have very weak structures, and you can also have very strong structures. And Ted Fujita actually recognized this or stressed this in his last, really in the last years of his scientific career, and a lot of people agreed with him, and it was one of the important reasons why this enhanced Fujita scale in the US was introduced, because the previous scale didn't give enough guidance to how to deal with structures with different sturdiness. But there was a drawback also of the EF scale, at least one that was quite notable for us potential users in Europe, that these objects that can be damaged, they're really very different, and they're not only very different from each other, but also very different from the types of structures that we typically see in Europe. For example, if you take the example of an elementary school, then you can have an elementary school somewhere in the central US, but you can also have an elementary school, well, somewhere in Africa. Or, and this probably is the fanciest elementary school that I know, is the one right in Wiener Neustadt, where we're located with ESSL. This is an Austrian elementary school. I'm not sure that that is typical. Maybe there's also very weakly built elementary schools in Austria. I'm not from Austria, so I'm not that much of an expert of that. But we came to the conclusion that properties of the international Fujita scale must be, first, of course, that it is broadly applicable, also that it should be accurate. So it should both be have a sufficient accuracy and be backed up by science as much as possible, preferably some kind of measurement of the wind speed. Otherwise, maybe by modeling, by computer model, or at least it should be following a logical reasoning. And it would also be important that the level of accuracy is reflected in the precision that the scale uses. So actually here what you can see is a whole range of different scales that are used for rating tornadoes. And if you look at this, what you can see is that there are some scales that are, well, that all the scales differ from each other. That's maybe the most difficult thing, or the most complicated thing. So there's the original Fujita scale, there is a Toro scale, and there is also the EF scale, the Canadian EF scale, the Japanese EF scale, and now there's also this international Fujita scale. But we try to follow the original Fujita scale, but in order to reflect that we think we can have a little bit higher accuracy at the lower wind speeds, we actually allowed for these lower ratings to have a minus or a plus. So you could have an F0 and an F0 minus, an F0 plus, an F1 minus, an F1, F1 plus, and so on. You would have a little bit finer division there. So how does this scale work? Well, we copied everything that we thought was really good, and that was really very useful from other methodologies. So we took the enhanced Fujita scale and we looked at damage indicators and degrees of damage. And we took some of these damage indicators, so these objects that we would assess for damage from that scale and from the Japanese version and from the Canadian version. And we made a whole list of these things, and it is actually a longer list than this. Actually, we have just finished a workshop on this topic last week, so that's why it is fresh in my mind. And we decided that we need some more objects as well. So how would this work? Well, this is a very important damage indicator, a building. And in this case, we would not look at the function of a building. In this case, this destroyed building here, we would rate it by using this flowchart and first look whether there is damage to the walls or the frame. There's two categories of structures. Some use mass walls that support the weight of the building. The other type of category of buildings actually has a frame structure that supports the building. And in this case, of course, that is completely, or it's completely clear that it is damaged. So we would go to a table called B, and there we would look up the amount of damage. But we could also assess the damage to the roof or to other elements of the building, and so on. And then comes an important thing, that we would not look at the function of the building, but instead we would look at which level of sturdiness it has. In this case, this would be a building with sturdiness E. This is the kind of guidance you will get from the specification of this IF scale. And then you look at a building of sturdiness E that is partially destroyed, and then you will arrive at the rating. And in this case, this was one of the instances where this tornado, this is the destructive tornado in the Czech Republic last year, was rated IF4. And using this whole methodology along various portions of the path, we were able to work together with the Czech Hydrometeorological Service and with their partners here on this side of the border in Slovakia and in Austria as well, to get this spatial map of where the tornado was more intense. So the different levels of intensity we could map here, and we could also comment on this damage, and we published this in a report. Now, going away from tornadoes, we also have our ways, and this is a little bit different level of damage, but this is the hand of one of our employees, and this is a way how we can ensure that actually our hail data that we collect is accurate. So we devised this guide here where you can just see how big a hailstone is compared to an average hand. And there's a lot of comment on it that if the hand is smaller, of course, you need to adjust to that. But we also try to get a good hail data in the database. But even if we have good hail data in the database, we have a correctly estimated hail size, still there are some issues with the data. Because if we look at how the data are distributed, if we just look at the database, you can see that there are some regions where many more hail reports come in than in other regions. For example, here, this is a little bit, this is quite close to where ESSL is located and a little bit to the south of there, actually. That seems to be an area from which we really get a lot of reports because of the good collaboration with the Austrian volunteers. But actually, this is not unique for Europe, because if you look at the Storm Prediction Center database in the United States, you see that you have a very similar problem, that actually some locations where a lot of people live, or even a lot of meteorologists live, that are really overrepresented in the statistics. So what can we do to still say something about important questions on how to forecast such events, or on answering the question, what do we know about changes because of a changing climate? Well, to do that, we have actually been working on a statistical model that makes a connection between the data that is available in a numerical model or in a reanalysis model and the actual observations. So if you would look at the reanalysis data set, such as that from, such as ERA 5 from ECMWF that we have been using, and you would look at the, a number of parameters that you can calculate from this data that you know are very likely to be correlated with hail occurrence, for example. You can plot it. And you can actually see that in this case, this instability measure, a variety of cape, and here a sort of wind shear, two of the essential ingredients for hailstorms, that we can actually see that indeed with a higher cape and with a higher wind shear, the probability of hail actually increases. And by developing a model fitting this data, fitting some function to a data, and then applying this function again to the model, we can very nicely extrapolate to regions where we do not have good observations. And that is what my colleague Francesco Battaglioli has been working on, or is still working on for his PhD. So here's some more technical information about it. We actually found that there is one particular type of cape, of convective available potential energy, that is really important for hail formation, which is the cape above the -10 level, which is really high up in the storm cloud, where of course the temperature is so low that hail formation is very likely to take place right there. And yeah, so we have a number of these statistical models developed using such a thermodynamic measure like cape, using also a wind shear measure, using some other parameters that we could derive from the reanalysis that were also very skillful. And using this information, we were able to reconstruct the hail probability across Europe. Here on the left for hail of 2 centimeters and larger, and on the right for hail of 5 centimeters and larger. And it is quite clear that you can see some of these regions that we know are really very hail prone, like here in northern Italy, but also southeastern Austria, the area we saw earlier on in the observations, and also parts here of Spain that have been hit in the last few days. Maybe you've noticed that in the social media and in other media, there were a lot of reports of very large hail in northeastern Spain. So this corresponds very well with what we would expect. And we can do, of course, we can do the same for North America. And we could, of course, also do the same for South America. I know we have a lot of people who are now listening to my talk from South America. So this is also in principle possible. Now, what we want to do next is to look at climate change and look at a longer period of time and see what happens. And a researcher who has also worked for ESSL in the past has already done this in the past. We're not there yet with our current research, but in the past we've done it as well with a coarser data set. And there were really strong signals that hail probability would increase quite a bit here, especially in Central Europe and in Southeastern Europe. And yeah, this is also shown in this time series here on the right. Actually, it seems, and that is confirmed by our latest results, that the probability of severe weather and especially hail has increased quite suddenly around the year 2002 to sort of higher level, and actually that it has been increasing quite a bit since 1919 altogether. And what you can also do is to look at projections by regional climate models. And Anja Redler, who made this last slide also, or the last pictures, she also did this analysis where she looked at an ensemble of 14 different models and looked at the probability of hail based on these models. And by doing that, she actually found that there's a quite consistent signal that across Europe, and the occurrence of hail will increase quite a lot. This is, yeah, let's say just the period that we've just entered, and this is around the end of the century. And if you take a stronger climate scenario, this RCP 8.5, which is like the business as usual or even slightly worse scenario, so it's not a very likely scenario, but if you take that, you can see increases in large hail occurrence of over 100% in parts of Central and Eastern Europe. Now, there's a completely different application of these statistical models, which we call ARHAMO, for Additive Regression Convective Hazard Model. That is our nice acronym. A completely different application is to apply these to forecasts. And now, if you recall this this case with this derecho over the Mediterranean that I showed earlier, this is the same day here, and this is the probability of hail in the background with these blue and reddish colors that is predicted by that model. And overlaid are these hail reports that we later received from our partners in the European Severe Weather Database. And you can see that there is really a nice correlation, so that the forecast by this model was quite accurate. Of course, there's also large areas here that are water, so we don't have reports there. And there's also some areas where the model was over forecasting, but overall it is quite a good, it's probably quite useful to have. And we're now really looking at the performance of these models for this usage. Yeah, so that we can write a publication and then have it better established. So as ESSL, we also are interested in this forecasting type of work, or supporting forecasters, especially after we opened our second center in Austria, where our lead, or our senior researcher, Tomasz Buczyk, and his colleague Christoph Gatzen, they give frequently courses to forecasters from various countries in Europe. who then come together there and really work, I would say, in a really hands-on way with forecasting. So it's not that they will be given PowerPoints during the whole day, but they're also given real cases that they then have to forecast. We sort of simulate the weather that has happened in the past, or we just go back to the weather in the past, and we show them the weather data that was available at a certain point in time, and then they have to apply the concepts that they have been taught earlier on. And in that way, we try to teach forecasters how to best anticipate severe weather. But for those who want to go a little bit more into the depth of understanding severe convection, who want to not only have this applied part, but also want to know the theory really at a very deep level, we also regularly organize courses on the dynamics and prediction of severe convection, where we really work with formulas a lot and derive a lot of these basic concepts that help to explain how severe convective storms behave. And occasionally we also have a number of other type of events like summer school. Of course, recently with the corona pandemic, we had a lot of courses that we could only organize online, and we overall went a little bit down with the number of such activities that we were able to organize. Then a very important activity is the Essl Test Bed, which we, of course, we were inspired to organize first after learning of the hazardous weather test bed, which is an event taking place in Norman, Oklahoma, at the test bed at the weather center there, with involvement of NSSL and the Storm Prediction Center and Oklahoma University. But we wanted to do it a little bit differently, because we wanted to do one thing really in a similar way, namely we wanted to evaluate new forecast supporting products or new forecast supporting tools. But in addition, we also needed a stronger training component in order to get like everyone in Europe a little bit at the same level of knowledge of forecasting convection, because there was really quite a strong difference from one country to another. If you consider the level of knowledge of convective storms. So what we do there at the testbed is much like I described before what we do at the courses. We jointly make forecasts and nowcasts in small teams, and we verify these forecasts afterwards against observations. But in doing so, we also evaluate new forecast supporting tools. There's a lot of discussion also with the developers of these tools, whom we always invite to come over and join, and who are also, if they're not on site, they're available online, so that there's a lot of exchange about the experience of particular tools. And I will give some examples of these tools later on. And there's also some of these experts who will actually talk either about how to forecast severe storms or how to interpret particular forecast tools, like model data or radar data. And this is an example of such a forecast. This is not a nowcast, but really a forecast for the rest of the day, where the forecasters were asked to indicate the area of highest probability of severe weather. And in this case, this was a very good example. Of course, there's also bad examples where the wrong areas were indicated. But this shows that the severe weather reports really happened within these red contours, which is a good thing. Overall, we've had 11 editions of the testbed since 2012. And in the meantime, over 400, maybe we're approaching 500 unique participants from a lot of countries, and usually people are really happy when they leave us at the testbed. So that's of course very nice for us organizers to see. So some of the products that we work with, well, there's a whole range of different products. but for example, there is numerical weather prediction models that of course have different predictions, and then we compare it. This is an example of a modeling system from the German Weather Service and here from the Austrian Weather Service, and we compare them to each other, but of course also to the radar, which in this case, again, it is this case of this tornado that happened a little bit later right here with this big cell, this tornado in the Czech Republic. Of course, we really looked very carefully at how these various models performed. We also looked at we also have the collaboration with ECMWF to look at one of their predictors, one of their variants of the so-called extreme forecast index, which shows you how extreme the cape and the shear, so the instability and the shear, is compared to the climatology. And yeah, you could see that even a very long time ahead, the area with the highest severe weather on this particular day was indicated quite well. But there was this is almost a week ahead. I think six and a half days ahead. There were still also a lot of false signals here. But as you approach the time 2 days ahead, there was a really clear signal that severe weather would be likely here. But there's also some other areas that need some further investigation. And yeah, that is exactly the type of thing that we do. We then contact the developer and we discuss why a product would perform better in one area or in one case than in another. Another example here would be a cell tracking and intensity monitoring system from the German Weather Service, where it uses especially the radar to track cells and to forecast their motion in the near future and estimates the severity of the cell. And now very recently, or I have to say last year actually, we've started a new collaboration, quite intense collaboration with EUMETSAT, because EUMETSAT is the European Organization for Meteorological Satellites, and they are launching a number of new satellites, the third generation of meteorological satellites, or MTG. And these satellites, the first of which will be launched by the end of November this year, carries a number of new sensors that are really unique, that are new altogether, or that are new for Europe. But in this case, we will have the FCI, the Flexible Combined Imager. That's what it stands for. It is a new imager that will have a much higher resolution than we've had before, and it will be giving, together with the second satellite, it will be giving a much higher frequency of data, and it also has a few new channels on it. And then there will, for the first time, be a lightning imager available for Europe and parts of Africa, which we're very happy with. And there will also be, with the second satellite, a so-called hyperspectral sounder, which gives you vertical profiles of temperature and humidity, all from the satellite. So this is all very interesting for nowcasting. So that is why EUMETSAT has teamed up with us to organize testbed weeks and expert workshops, which we will be doing during the next few years. And we've already started that, actually. And we will always do an impact assessment after we've carried out a test bed. So that means we will ask the forecasters what kind of impact the new things that I've learned by working with this new data, which kind of impact it has made to them. Like, have they really started to use tools that they didn't use before? Do they think they're very helpful? And of course, during the test bed, we're already having this feedback loop of where they can say what kind of aspects of a particular product they like and what they don't like, and how we can improve these products. And one of the first things that we do is that, of course, until this first satellite is launched by the end of November this year, and sometime after, we will not have real data to work with. So what we have been doing is to use some data that can be used as a proxy. And one of these products is this product, a low-level humidity product based on a new type of channel that this new MTG satellite will have, the 0.9 micrometer channel, which is near infrared. And this is a channel that actually, the radiation at that wavelength is actually absorbed by water vapor. So you can see very clearly which areas are dry and which areas are humid in the atmosphere. Yeah, we've been using this for a number of case studies, like, for example, this tornado case, where you could see that it was really humid around that location. Actually, it's a little bit purple here, so we made a nice color scale there as ESSL. And yeah, we are looking at the usefulness of this product. But of course, this will be especially interesting when we have data from the real geostationary satellite that will not give this data only a few times per day, as when this MODIS sensor passes over, because that is a polar orbiting satellite. But when the real data is there, we will have this data every 10 minutes. Now, in order to visualize all this data at ESSL, we have developed this web paged, or this HTML page based visualization tool, where we can display a lot of different data, radar composites, satellite data, model data, and we can also draw the forecast right into that website. And this tool, a lot of people like it because it is really quick and loads the data really quickly, because the data has been prepared ahead of time. And that is why both ECMWF and EUMETSAT would really like us to deploy it in the European Weather Cloud. And this is now something that is ongoing, that we're putting it into this so-called European Weather Cloud, which is a cloud-based computing environment that ECMWF and EUMETSAT have started. Yeah, so this is work in progress, and what is coming up now in the coming time, this is my final slide, are of course more courses and workshops. We will have more of these test bed weeks that we organize together with EUMETSAT. We actually very soon, on the 27th and 28th of September, we have a mini online conference on severe storms. So if you want to know more, look at our Twitter channel, or go to our website, essl.org, and you will find more information on that. This one is actually completely free. And there is also a real on-site conference in the series of European conferences on severe storms planned next year in May in Bucharest in Romania. And of course, we would really hope that we can welcome scientists from all over the world. We usually have a really high attendance at that conference from the United States, but also from some Asian countries. So we would really like to welcome people from other regions like South America or Africa, for example. And with that, I conclude my presentation, and I'll be happy to answer your questions.
Okay, Peter, thank you so much for your presentation. It was very nice. And I would like to encourage anyone who has any questions to post them here on the YouTube chat or in the Google meeting too. We'll just wait for a few seconds if someone come up. Yeah, there's one question for Marco Josevicius here. Is it possible to submit applications for ESSL training for professionals outside of the European community, and how to do it?
Yes, in principle, everyone is welcome to join. Of course, the funding is always a point that needs to be solved somehow. But if you indicate your interest, we're also happy to help you look if we can get an external sponsoring. Sometimes other organizations are happy to sponsor you. Occasionally, we can do that as well. So just get in touch with us. Send an email to me or my colleagues. You can find our contacts also at our website, and yeah, we'd be happy to receive email from you and see what we can do.
Okay, and also regarding the trainment, Peter, can you tell us about like how was your experience with dealing with very different countries with different languages and everything? Like how did you start with this training part of the test bed that you have in Europe? And what recommendations do you give for if we want to do something like that in the future in South America, for example?
Mm-hmm. Yeah, I think actually many of the practical problems can be solved if you have really enthusiastic, interested people who want to learn. And mostly we had a lot of we had really the participants from the countries who really wanted to learn things, and occasionally their English, because we've only spoken English, we were not able to develop course material in other languages. But even despite their somewhat limited knowledge of English, it was usually in those cases quite possible to teach quite well. I think sometimes the different levels is difficult. So that is why we have this sort of basic course where we really start at the basics. The most difficult thing is if you have to unlearn some things. If we think like, well, this is not the best way to do a particular forecasting problem, like there's a lot of people like, well, if I give an example, there are sometimes forecasters, and it was much more in the past than now, but that they would look at fronts that were analyzed on a weather map. And these fronts, they were like, there was a front moving across Poland, and then they would try to explain why there were storms in Croatia because of the front being a little bit closer across Poland or something like this, like things that really don't make a lot of sense. And instead, what we try to do is really to use, I would say, the findings from science, where we know that storms at least need a number of basic ingredients like lift, moisture, and instability. And we go through examples with the participants and show them really that if you look at where these ingredients come together, that is where the storms are most likely to develop, that they really see it by themselves. And then, of course, if we give them an exercise and they find out that it really works, and that it even really works over their country, hopefully there's a case that we can look at that affects their country, then they get really into that. Then they start to believe it. And then, of course, if we have to go to this very basic level of training, and this has been quite a challenge at the test bed, we don't get so much, we don't have so much time or mental energy left to spend at evaluating new forecast tools, or maybe they're not even there with their understanding that they can contribute to that. So it is always a little bit of difficulty, and that's why we also have some of the testbed weeks for which we will invite people whom we know are really already quite far and who are really advanced forecasters. So that in the other weeks where we don't know who will come, and there could be some people at a somewhat lower level of understanding, that we can take the time to help them and understand the basics first.
That's cool. Yeah, there's another question here from Avinash. Is it possible to use an ensemble probability forecast to improve the predictability of storm forecasts? And if yes, what threshold of probability will work better as per your experience?
Well, that's an interesting question, because I briefly showed this stormforecast.eu website that we have, where we have this statistical model that gives you a probability of severe weather. And there, actually, we are not yet using ensemble forecasting, and that is something that we're planning to do in the near future. Now, the only thing that we do there is that we use some kind of poor man's ensemble that consists of 3 different models, and we take the average probability, in this case of lightning and of large hail, that we get from this model, and that is what we use, and which seems now anecdotally, or just by looking at the number of cases, to work quite well. But if you want to use an ensemble, hopefully you will get even better prediction, especially a number of days ahead of time. I don't know which kind of threshold of probability you would like to use, because I think that is something that would really depend on what you're forecasting for. If you have an event that is very costly to cancel and the risk is limited, then maybe you choose another probability than if you have something that is very easy to cancel, and the risk would be really big if you would be hit by a storm, for example. So that is not really general something that you can give a general answer to.
Mm-hmm. And just a follow-up question: how many countries in Europe run like convectional anomaly models, for example? And is there a plan to run like an ensemble or something like this in a domain over Europe, or in the future?
Well, we are really a small organization, and we are actually not. We have the European flag in our logo, but we're like not some part of a big European administration. So we're actually really really happy to work with others. I mean, that makes it very easy for us that we don't have a lot of formal rules. Ultimately, the members of ESSL, and these are individual people, and the members who have a voting right are the weather services in Europe, and these individual scientists, they determine what as ESSL we should or should not do. We also have an advisory council who advises us. So we're actually, as long as we really follow these goals that we want to pursue science, we're actually really, really free in doing that the way we think is the best. So we don't have all kind of bureaucratic rules. So I think that is a very good thing. The thing about starting collaborations as a small institute is, of course, that if you have a collaboration, we need to make sure that it is also really valuable to us, because the fact that we are with so few people means that we don't have a lot of freedom to spend a lot of energy and time into a collaboration. But I'm really happy to discuss any options and see if we can collaborate with other scientific organizations or within programs that I don't know yet. So I think in this case also just contact us if you have a concrete idea, and we'd be happy to discuss it with you.
Rachel, do you want to ask questions?
Actually, before I have one, but before that, there is another question from Marco Josevicius. What is the SSL's policy to develop technical scientific cooperation programs with other institutions? Are there preconditions that the candidate institution must have?
That is the question that I've tried to answer.
Oh, sorry.
Yeah.
It's not on. Oh, it's not on the. I lost my connection. Sorry for a little bit.
I hope the answer was sufficient.
Yes, but there's another one from Pedro Augusto. In regard to the reports, how are they collected? The general population feel them, like through social media or an app?
Well, yeah, you can go to the, or anyone can go to the website of this database, which is eswd.eu. I put it in the chat here. and everyone can go to that address and submit their report. So if you have experienced some severe weather in Europe, or within, actually we're also covering North Africa and parts of Western Asia even. If you have experienced severe weather there, you can report it. But we see that not so many people do it, because as I also explained, we have like a whole list with that you have to click which impacts occurred, and it's a bit cumbersome. So it's really the sort of the fanatics, the people who really enjoy doing this kind of work, who do this for us. So there's also some places in Europe where we actually would like to find more of these people, but the number of people that we have found in a number of places, they really do a very good job. So yeah, in Poland or in Italy, there's this whole network of weather enthusiasts who collaborates with us. We have actually some kind of exchange of the databases, because they already have a database at the Italian national level. So that is a place where it really works very well, and we hope to get to the same high level, of course, everywhere in Europe. But in the end, another source of the data that is very important are actually I would say the 1 and 2, 3 employees that we have. So we have one person who works full-time for us to collect such data, and then there are 2 others who also in part-time help us to collect such reports. So they really have some tools where they have ways to filter Twitter, for example, or where they have Google alerts to alert them to certain words being used in news sites on the web. So they've become quite efficient at collecting the right information. Of course, you always need to know, at least as a minimum, the place and the time, and something about the intensity of the event. And it's not always easy. Sometimes these media reports miss something of that, but they are really, I would say, the most experienced people to do that, along with some of these volunteers that work with us.
Yeah, we have started actually a similar database. I say we, but then who actually works on this database is Bruno here, and also Guilherme Schild. So they are the tools in Brazil that are collecting and doing every day. So they spend a lot of their time, their week time and the work days doing that. And so I have a question on this. What were the challenges you had and still have in building this European severe weather database? And do you have any advice for us?
Yeah, I think the most important is that you need to identify those people who are already interested in this topic, and who are really willing, especially initially, to do this kind of data collection work voluntarily. I think that has been we have had a big luck with the person who, when this database was not even part of ESSL yet, already started to enter reports into the database, just because he thought this is such a nice thing to do. And then, of course, with that we have been really lucky. And now, of course, he is our paid employee, and we also have the other 2 part-time paid employees who also do really a good job. But even if you cannot pay people to do this, some of them really in different regions probably of your country, you can find a few of those people who are really worth their weight in gold, so to say. They are really important to find. I think otherwise, what has helped us as ESSL, of course, we wanted to ultimately not be an association, as we started, of individuals like scientists who have other jobs, who are interested in severe weather, but who do not really work, like who cannot really do a paid work for that, because that's how we started, really with a only sort of first an informal network of people who are interested in the topic, and then of course you at some point you want to get funded, and I think in our case also the German Aerospace Center, that was an institution who helped us quite a lot in the beginning to submit some project proposals from which we could get research funding. And also in our case, the data from our database until this day is not really open data. So it's not that anyone can go to the website and download all the data, which we actually all at ESSL think should be the case. But the way that we do now is that if there's anyone who would like to use the data commercially, they will have to pay for that. They have to pay a fee, or they have to become a supporting member of ESSL. And then they pay an annual membership fee. And that, of course, helps us then to sustain this data collection work. If you, as an academic, you would like to use the data, then we will first ask, well, are you working for some project? Do you have some funding from your project? Can you also contribute a little bit to us, so that we can also sustain our work, and then we would be happy to share the data with us for your work. And if you're not if you are a student and you just want to use it for your bachelor's thesis or for your master's thesis, and you're not doing that, then we say like, okay, well, we're here to promote science. You can get the data for free, but just for this project. That is how it works. We hope that ultimately, and that's also something we discussed just this week at another meeting, we really want to convince like the European Union, that will be like the most logical place to look for, to just afford spend a little bit money on doing something that is really used so widely by scientists. So we want to get some institutional funding to support this work.
Yeah, those are nice. Good
and every
advice.
data, all the data can then be open, and that will be so much easier for everyone.
We already found our two enthusiasts, Bruno and Guilherme. Now we need to find more.
Maybe a few more, yeah.
Yeah.
Brazil is large.
Yeah,
South America even larger.
Yeah, I think it is a matter of us getting together and build some initial volunteer network, something like that. We'll start thinking on that. So we have another question here from Philip. Are there any plans on expanding the international Fujita scale to more regional damage indicators regarding, for example, different architectural styles and standards from different European countries?
We try to sort of address this by not developing very specific standard or very specific damage indicators. We say that a particular structure or a particular object typically has a given strength, but then on a national level or on a regional level, if you have maybe you have a particular way that houses are built in your region, then you need to see like which kind of sturdiness level does it have on the international Fujita scale. Of course, we will give guidance in the document what you should look for if you want to assign a particular sturdiness level to your building. But that is the way we try to approach it. In the end, of course, there's a lot of details that go into the architecture. In the end, we should also realize that maybe it is sufficient to just use sturdiness levels instead of really going into the details of how structures are built with which kind of material and which kind of connections. We think it is doable to summarize that into like one generic level of sturdiness for a building. But if there's very deviating things that are not covered, then of course other things can be added to the scale. Other damage indicators can be added, and we'd be open to your input. If you have a particular suggestion, then we're very happy to hear that.
And I have a question on that. Who does the damage assessment on that in Europe?
Yeah, that's the point. That's a very good question. So actually, there are very few weather services who do this regularly. At least by no means all weather services. There's a few weather services that I know of, like in Spain and in the Netherlands, and well, recently, of course, where is some areas where there are where some very severe events have happened, weather services have now gotten a lot of knowledge, because they, for the first time, they they encountered such a strong tornado, for example, and they had to go out in the field and they had to brief the media and had to tell the media like which kind of intensity did this tornado have and how rare is it to have a tornado of this intensity. But actually, yeah, there's very few weather services that are well prepared to do such assessments. So when the tornado happened in northern Italy, and we as ESSL saw images, and we thought, well, this could be a violent tornado, so at least F4. Then we say, at least we as ESSL want to be there on site to also look at the also contribute to the damage assessment effort there. And the same in the Czech Republic last year. There we did the same thing. So we're now actually establishing a list of people that are very sparsely distributed across Europe, people who have some knowledge on how to do such damage assessments, so that if a tornado happens in a particular location, we know who lives relatively close and who could help us as ESSL with doing the damage assessment. But if we're talking about sort of frequent tornado type, like or an intensity that is not so exceptional, then of course we cannot afford as ESSL to travel there. So only if it's a violent tornado, we will definitely go there. Or if it's potentially a violent tornado, then we have said, yeah, then we need to go there, because then it is important enough for us to really go there.
Yeah, I imagine that would be not a very standard thing, because you guys are composed of very many countries.
Yeah, and in each small country, of course, a very extreme event is really rare, because these countries, yeah, they're so small. If some severe events happen, the chance is much larger that it was in a neighboring country, not in yours.
Yeah. So, okay. I don't see any other questions on YouTube or here at Google Meet. So I'd like to thank you once again, Peter. It was a very nice presentation. I enjoyed very much. And for sure, we'll get in contact with you again, just to get one-to-one with our committee with several other questions that we'll
yeah, it will be my pleasure.
Okay, so thank you again, and thank you everyone for watching and participating on our webinars, and we'll have one more in just 1 month from now. Okay, so bye everyone.
Okay, goodbye everyone.